Is Saif Ullah, registration number 20T54. Here is the lab number 5, and we in this lab there are the 4 tasks. First task number 1, in this task there is a discrete Fourier transform, and we are calculating discrete Fourier transform and inverse discrete Fourier transform, and here is the theoretical formula. And now we apply this formula in our MATLAB software to get output. So first we make a function. So there is a task 1, and in this task the owner is asked for my DFT and my inverse DFT for calculating the given input x1, x2, x3. So here is the MATLAB code, and first we build a function y is equal to my DFT of x, n is equal to length x, y is equal to zeros, and n and 1 is the zeros of the output, and we apply the loop for k is equal to 0 to n minus 1, for n is equal to 0 to n minus 1, and the three ends are step by step closing brackets. So when we make our function and stored, then we apply our code in this MATLAB software. Here is the code of our first task. First we copy the input from our manual, and y is equal to my DFT of x, and this we put a function disp and display, and display inverse for Fourier transform and display inverse Fourier transform, and now we get output. So here is the task number 2. The task number 2 is the input are given x1, x2, x3, x4, 5, x6, x7, and we apply this input in our MATLAB software. So here is we copy the input from manual, and we put the command stem. The stem command is used for digital discrete signals, and here is the output of our discrete output, and there is the in the discrete Fourier transform and inverse discrete Fourier transform sequence in the command window. So the task number 3 is the use of MATLAB to build in function. So here is the input, and now we are applying, we are clearing all the data, CLC, and so we put input 1, 2, 3, 4 x of f of t, first Fourier transform, and here is the output x is equal to 10 or plus 0, or those. So match our output of MATLAB from manual output, so both are same. So the next command is x of real is equal to real, x of real is equal to 10 minus 2 plus minus 2 and 2, and again both are same. And this is for real part, and now this is command for imaginary part. X of image is equal to image. This is the built-in function command in MATLAB. So we put again and again and get our outputs. Now here is the task number 4. Calculate DFT and plot magnitude spectrum, phase spectrum, and power spectrum. Now I am also learning in our theory classes how we plot the magnitude or power spectrum. So for using task number 2, here is the input of task 2. So we put x of 1 is equal to f of t x1, x2 is equal to f of t x2. There is a built-in function. So x of 1 is equal to magnitude absolute x of 1, phase is equal to angle x of 1 is power is equal to x of 1 magnitude into 2. So this procedure are continuing with all of the inputs, and the title is equal to magnitude spectrum of x of 5, and x label for x-axis, y label for y-axis, and now This procedure are same for all inputs. So subplot 313 stem x of 5, this is for x of 1, x of 2, x of 3, x of 4, x of 5, just changing the x of 1, x of 2 index. So here